And so those people that do know us or don't know us, you may be surprised as to why is Global Inkjet Systems doing this particular presentation? Don't we just do electronics? Well, we do a lot more than that. And a lot of it's to do with our RIP technology, the different software utilities that we provide, the user interfaces and components for ink delivery systems that mean that when we're working with machine builders, we get really involved in helping them maximize the capability of the machine that they're building and designing and getting the best possible output that they can from it. And like any component supplier in the industry, I'm sure all the printhead manufacturers and the ink suppliers out in the audience will empathise me when I say this. But if anything goes wrong, your customer will always be on the phone saying, it's your electronics that they don't work, it's your ink, it doesn't work, our system isn't good. So we spend a lot of our time transferring our knowledge and helping people understand all the different aspects that need to be brought together in order to build a good system. Because although it may look simple, you take a head, you take some ink, put it all together, make a little single pass system. I mean, how difficult can it be? So it may look simple, and getting to that first print often doesn't take very long. I mean, we will work with customers that will be spitting ink probably within a couple of days of receiving all the different bits and putting it all together. And then the hard work starts. And that hard work can take 6, 9, 12 months, maybe even more, depending on the scope of the machine that you're building and putting all those pieces together and getting it to work, not just for a couple of hours in the lab, but getting it to work 24/7 in a lot of the different industrial applications that Inkjet is now moving into. And then when you've done all that, the end result is ultimately whether the customer is going to accept it. And that definition of print quality, is so subtle. There's all the qualitative definitions. Does it just look right? Are the colours right? Colour matching. Of course, is it functional? Do the barcodes read? Is everything really legible and sharp? But importantly, we've got some very good quantitative definitions that we can use of the physical parameters, of things that we can check right from the fundamentals of putting the machine together. In terms of, the drop placement, building the machine so accurate that you're going to be able to control as much as possible. The drop quality goes back to, getting the right ink development and analysis right from the very start. All these edge acuity and line quality, how accurate is your system, and the control of the substrate in that. Optical density, and of course, functional attributes. We've got many people now new to Inkjet coming in that don't really care about the technology. They're just using Inkjet as a deposition device because it's part of a manufacturing process. They just want something that will jet a type of fluid in a specific area, and it's got to work. And quality issues, I say this is just a few, because these are all the types of things that come through on the technical support emails to us. And the list, I'm sure other people could add many, many more to that. All sorts of different things. All of them have potentially different root causes that need to be analysed and gone through a very systematic step-by-step approach to understand, why is this happening? What can we do to fix it? And we sat down a few months ago and tried to put together in one slide all the different things that can affect image quality. And I'm sure this isn't comprehensive. I'm sure the people in the audience can say, oh, you haven't mentioned such and such thing, you haven't mentioned that. But we've tried to capture some of the main ones. And as you can imagine, in the time I have, there is no way I can cover all these and give them all equal weight. So in the time allowed, I'm going to just pick one or two of these. But just to give you a flavour, but you can always go back and refer to this. And there are lots of other presentations over these 2 days that are covering a lot of these other areas that I won't cover today in much more detail. I mean, for example, we had Martin Bailey from Global Graphics yesterday, talking about screening. We've got Colourgate this afternoon talking about colour management. So there's lots of opportunities over the 2 days to get a lot more in-depth into a lot of these different areas. So I'm just going to touch on a couple of them. And it all starts with the ink and the printhead. Printheads I'm not going to talk about in a lot of detail. We've got other presentations on that. But it often surprises us is, how people often take the ink and the fluid just as a given, and yet it's absolutely fundamental. We work with a lot of the ink and fluid suppliers because they are so important to the market. We don't have the right fluids and inks to jet. None of us have a business. So starting with the absolute basics is essential, and there are great tools available. We had a talk first on yesterday morning from Image Expert, talking about the products that they have. Most of the ink manufacturers now have this type of technology. So if you're buying an established fluid, an aqueous or UV solvent from one of the large ink suppliers, they'll have done all this work for you, which is great. They'll have developed the waveform. They'll know what temperature you should jet that ink at. All the viscosity ranges are correct for the print heads that it's been approved for. But if you're trying to get into taking something from an industrial fluid and trying to adapt it to inkjet, if you miss out this process, you're never really going to understand the fundamentals of the problems you're going to see further down the line. It's a step you simply cannot avoid and shortcut. Because if you start jetting with a fluid and you don't really know whether you're getting good drops out of it and start putting it onto a substrate, you're going to start seeing problems. Now, is that problem because you've got an issue with the substrate interaction, or is it fundamental with the fluid? So you've got to do this in a step-by-step way. And even with, you might take a well-established UV curable ink, put it on different substrates, you will get different results. And here in this slide, which I've got courtesy of Industrial Inkjet, gives you a good idea, a good understanding of here the difference in ink surface tension with the material surface energy and the differences that you can get. So you're really looking here for this sort of sweet spot up here where you've got maybe a 23, 24 dyne per centimetre ink surface tension and about a 50 material surface energy. And this type of work and understanding how different inks react on different substrates is very important. And that was one of the things that Steve just mentioned that is covered in that practical course, where you can take dyne pens and see how they show up the surface tension on different substrates, and then you can then take those substrates, treat them, and then see how it changes, and then it will work. And the other thing also is you will find that you can take maybe 3 different UV curable inks, try them on the same substrate, and you will get different results. There's nothing wrong with those inks. It's just you need to understand that they all are slightly different and will behave differently on different substrates. And again, there's an example here from some work that IOJ did with exactly this. 3 different inks, same substrate, 3 very different results. So understanding the importance of pre-treatment is vital as we move into printing on all sorts of different substrates, and plastics in particular. And again, here we've got a nice example of showing how a plastic substrate, with no corona and then with corona. So then moving on to some of the more mechanical issues that you can come across in a system, and in particular encoders, and media control, and then also ink systems. So accuracy of surface substrate movement, again, we've seen just last week how now there are lots and lots of different hybrid devices at Label Expo, people putting print engines onto inline with flexo machines. And that's been done for quite a few years. Now it's really becoming an important trend. You couldn't go anywhere at Label Expo last week without seeing a hybrid type device in every hall. And it's not as easy as people may think of just putting it on that line and having it work, because of you need to understand that what is good, accurate movement for a flexo press with the analog process doesn't necessarily translate straight away into working perfectly with inkjet, because any sort of that sideways movement will cause an effect with the output of even 0.1 of a degree. And again, here, this is a really good test that John Carell from Industrial Inkjet showed me a few years ago now. And if we could play that video, please. What he did is he just put a credit card at an angle onto a web and looked very carefully at this gap. and you'll soon get really just a nice visual impression of how accurate that web is moving. It's a very simple test. Another area that is a relatively low cost, small, seemingly inconsequential part of a system is the encoder. Don't cost a great deal. People still try and save a few pennies here and there. It's worth getting a really good encoder in your system, because the encoder is responsible for regulating all of the printing by determining, how much the substrate has moved relative to the print head. So it's really important. And choosing the right type of encoder and maintaining that in the system is also something you need to look at regularly. Because if you're using a linear encoder, like an optical or magnetic type, they can, if you start getting problems in registration, it could be that the detector is lifting off the strip. The strip could be getting dirty and you're not getting an accurate reading. On a rotary encoder, a rotary or shaft, the positioning of that is very important relative to the print heads. Sometimes we go and look at systems and the encoder is so far away from the print heads, there's a great potential for margin of error in terms of, because of that distance. Similarly also, a poor quality one, or even over time, you can get some wheel slippage, and that will also cause misalignment. Or the substrate may be bouncing or bunching as well, which will, can cause problems. And the resolution of the encoder is important as well, and it's often only maybe an extra $100 to get a high resolution encoder, and it will improve the results of your machine. And encoders can be very sensitive to signal noise, and and poor wiring can also affect it. They're very simple things, but they can have a big effect on the system. And one of the effects that they can have, amongst others, is you have problems with color registration. It's not always so visible on monochrome systems. As soon as you move to color, you can potentially see this, because again, if the encoder is not accurately reporting the movements of the media, then this is what's going to start happening. You're going to get misalignment and slippage. The media control, as I mentioned earlier again, is also very key, because on webs, media can stretch or it can slip, or the acceleration might not be smooth. And again, you will start to see these sort of errors where you get a partial or even a no drop overlap. And of course, then there are other things very fundamental, like the system setup itself. If the print heads are not aligned mechanically correctly or even offset properly within the software, you're going to have issues. And of course, the other thing we were talking about, Shane O'Neill spoke about yesterday, is the higher speed that you get in systems. This is always something that can have an effect on the jetting parameters and the flight of the drops. There are so many more things now that need to be built into these systems. And just to give an illustration of how little movement is needed to affect the print quality, here we've got a shift in both the X and Y on the top. It's not so visible here, but when you get the PDF of this presentation, you'll be able to look at this in more detail. But you can see if you've got both an X and Y shift, pixel nudge, you can see how the image starts from being sharp to being very blurry. And even if you only have an X-only shift in that image, you'll see that we go from a perfect alignment here to starting to look as if this lady has had a very bad night and drunk too much. Another fundamental issue that we come across on the mechanical setup is the ink supply system. And this has been something that we've seen more and more in the last couple of years, mainly because more print heads now need to have a recirculating flow. It's a much harder system to build reliably. And so a lot of the issues that are listed here are becoming much more prevalent in the market. And it's one of the reasons that we got into this business and started to supply components ourselves, to try and get to try and assist companies develop reliable systems. And these are just some of the issues that can creep into a system and will really affect the reliability and will reflect the type of output you're getting. So poor meniscus control, you can sometimes get heads just weeping all the time. That means that you've got a problem with pressure control. You may be getting some air traps in the system. And so, you need to be, if your system is prone to that, you need to then also design in some release points for that air. Dissolved air within the ink is something that, has been an issue for a long time within the industry. It's a well-known issue. But again, not everybody uses degassing. They should do. It's absolutely essential in an aqueous-based ink. But we're also seeing people now starting to use it to a certain extent with UV inks, again, to try and just get that little bit greater measure of reliability. And having the correct tube material, we've seen systems where they're using completely the wrong tubing, and it's actually, bringing in air into the system. Materials compatibility, obviously a very critical one, and often very difficult to diagnose if you haven't done that testing right from the start, and can be extremely expensive if you end up getting particles going into the printhead and just destroying it. Ink starvation is another one that crops up. We get calls like, I've got 3 heads jetting and the 4th one isn't. Often that could be traced back to something that's gone wrong in the ink supply system. It could be that the tubing's too small, the ink's simply not getting to the head. And so you need to build in, you need to be able to design your system so you're avoiding any of those types of restrictions. Poor pressure control generally, particularly important when you're recirculating ink. You want something that's got a nice smooth flow, not something that's pulsing. Sedimentation, of course, if you're recirculating, that can help a lot to avoid, and avoiding collection points. And also just your basic choice of components. We've seen, pumps that are not reliable. Again, they were cheap, thought that it would be, is it really important in the system? Shall I save a bit of money there? Our advice is no. Always get good quality filters, get good quality pumps, and then you'll have a reliable system. I've talked about flow modes and recirculating. So just to recap, a lot of heads don't need any recirculation. They're what we call no flow. They're end shooter. You'll hear all these different terms. And that applies maybe to maybe a Konica Minolta type head, or a Ricoh, or a Kyocera. It's an end shooter. But those printheads often can work in a low flow mode as well. And that can often be beneficial depending on the inks that you're trying to jet. So even though you might hear about a printhead being called an end shooter, it doesn't need recirculation, it can often be made to do that because it's got the in and the out inlets for the ink. And if you're using a white ink, for example, or a functional fluid, some sort of gentle flow can often be, add that extra measure of reliability. And you can just do that with just the height difference in the chamber. If you're talking more about a ZAR 1002 or a Fujifilm Starfire printhead that really need what we call an adjustable recirculation of the ink, then you need a system that has good pressure difference control within it. And there are different configurations. Ink supply a good ink supply system certainly can add cost to your end machine. So it makes sense on if you're doing a CMYK, you can just have a shared pressure control. If you have got maybe working with difficult fluids, or you specifically want, or you've got a very large system with maybe very large wide bars, you're probably going to want to have independent pressure control on every ink. Or you could even mix it. We've got customers that have gone for maybe CMYK with a shared, and then they've done the white with a low flow and an independent pressure control. So you can mix the systems and choose what the best is for the to get the optimum reliability. And as systems get larger, the whole issue of stitching printheads becomes more and more critical. We all know scanning is traditionally known as safe and reliable. Your errors are recoverable because you can multipass. But the trend for higher productivity is for single pass. And of course, this is one of the areas that probably up until 6 years ago was one of the areas that made people very nervous about using inkjet in single pass. But so much has developed now in terms of jet straightness, the reliability of the printheads, which is why the single pass market has exploded so much. But it's still an area of concern. And what we're finding now is that as you more and more printheads now are getting smaller and smaller drops. 1200 dpi was the big bars at Label Expo last week. Printheads, jetting tiny drops to create beautiful output, but it doesn't come without challenges. There are a number of different technologies. We have one in a software where we can actually compensate for a missing nozzle. Doesn't work if you've got two nozzles together that are blocked out. But if you've got one nozzle in one area and one in another, there are a few tricks that you can play to disguise, where that nozzle has gone. So with a loop, you can certainly still see, where you use this technology, but it's a good medium-term way of extending the life of a printhead until you can maybe swap it out or do a service call or a purge. Similarly, as you get large bars, you will find now that more and more, or it becomes more apparent, that there's often a small amount of non-linearity in the drop volume across the length of a printhead. And that can become, when you're doing XY, it's less apparent, but it becomes much more apparent when you've got a very wide bar of printheads. And disguising that join becomes more and more difficult. There are techniques to be able to compensate a little bit for that non-linearity. We can do it in software, and there are other techniques as well. So again, exploring all the options and exploring all the capabilities that are available from suppliers is very important to optimizing your system. And we talk a lot about printhead stitching because it is so important. I mean, even last week at Label Expo, we could take print samples that people were giving out, and we could still see stitch lines. Not that visible, but they were still there. If you really looked for them, you could find them. And it just shows how difficult it is. The other thing is also, people tend to avoid giving out print samples with large areas of flat colour, because it's so difficult to disguise the stitch in those areas. So if you see somebody that's giving out nice big solid areas and they've got that confidence, that they've solved and beaten all these different issues. And so naturally, the more you've got an area of overlap in the printheads, the easier it is to create a good stitch. But of course, that's more expensive. It means you're going to have more printheads in your bar. But the other thing to bear in mind is, lots of different stitches will work better on different substrates, on different printheads, different types of systems. And so, it's important to play around and understand the output that you're getting from your system. So I've got a video. I think we've got time to at least run the first one, please. So what we've got here is, what we're trying to show diagrammatically is two print heads, but we're showing one print. They'd normally be printing at the same time, naturally, but we're simulating it separately. So that's a mechanical stitch of two heads that aren't particularly well aligned and have got a little bit of density shift. And what we're showing here is how different types of stitches can have a different impact. So now you've got that 50% stitch. You can actually see that band. It's to the eye, it's quite obvious where that stitch area is. Now, because we've got some misalignment of the heads here, if you use this sort of 2D XY dither, it actually becomes more exaggerated. And also there's potential for, this is not a good stitch if you've got any sort of media stretch as well, because you're going to expose white space. You can have things like a sinusoidal stitch. Again, if you've got any misalignment in your print heads, it's going to be exaggerated by this type of stitch. And yet, if you use this stitch, you can disguise a lot of the problems that you've got. So it's just one example. And I think actually, I think we do have time. We go on to the second video, please. So here, this is what we would love. We've got a print here of a butterfly. Everything's working beautifully. And whatever stitch you use, it'll be perfect. Well, that's an ideal world, and it just doesn't happen, unfortunately. So if we start adding errors, what happens if we're using that sawtooth stitch? Well, here now we've got jet straightness errors coming into the print. I hope you can see that. You're getting some lighter and darker. It's so not much that stitch can do to help that. It's very visible. Next, if we've got a web stretch, we're going to see very clearly that this sawtooth is a terrible choice of stitch if you've got any sort of web, because you're going to start seeing show-through of the web underneath. And if you've got printhead density, as I was talking about earlier, where you've got this density shift in one printhead versus the other, you can see the bottom one here is much lighter, again, that stitch isn't going to help you disguise that area of shift at all. But going back to our 1D stitch, doesn't solve everything, but it's not a bad compromise. So moving on, I mentioned earlier, software is such an enormous subject. I wouldn't even attempt to go into it in any detail, and getting the best out of your RIP, or even understanding what a RIP is, as Steve said, is a very critical area. I'm just going to touch on a couple of ones in my last couple of minutes. And that's really the effects of grey levels in output. And a lot of this is now, so many printheads now are coming up with more and more grey levels in them. It's great, it gives people a great opportunity, but you need to be able to manage that capability. So here we've got the effects of grey level, and showing exactly why we love using grayscale. Because the quality of an image versus the binary, versus the 3 level and the 7 level, you can see, here we've got much more detail. It's a much better quality image. But choosing which drops to use in the system, and you can do through software or through the waveform, is also a critical thing to think about. Just because you've got something that's got many grey levels in it, you don't necessarily have to use them all. Be selective. And one of the reasons what we want to draw out here is that if you have, for example, three drops with even spacing, you're going to get a much better quality than 3 where they're actually all bunched at the top end of the drop scale, or if they aren't as evenly spaced. So again, it's just something to be aware of. It can have a big effect on the output quality, as can, if you're laying down too much ink, you end up with flooding, and that's something else that we see with on some printed images. Again, when you get solid areas, it's clear that far too much ink is being laid down. This is a very simple thing. You can control it in your RIP, you control it in your software, and you may find that you simply don't need all the grey levels to get the optimum output. So that there are these tests that can run. I mean, here you've got an ideal tonal response on your 8 grey levels here. It's a nice, smooth growth in the tonal response. But this is often more typically what you get, where there's a bunching here at the top end. So you're not actually going to gain anything if you use that 7th and 8th grey level there. You're actually going to get a much better output if you simply reduce it down, and so you're not flooding the media. So that's my quick introduction to just a couple of the different areas that are important. And it's as Steve says, you're going to build an ink system. You need to have knowledge and expertise, ideally, in a whole range of different areas. So when you do run into problems, you can go through and analyse things step by step and systematically. So Inkjet is a wonderful technology, and everybody would be successful if it was really simple. The nice thing, I think, is actually it isn't that easy, but there are great tools and people to help you out there build a good system, and I hope this has been useful.
Thank you, Debbie.